Hey everyone, I'm Andrew, and welcome to my astrophotography image processing tutorial, which apparently I've been teasing on Discord since May of 2019, so it's probably time for me to get started. Anyways, my goal in this series is to turn the steep learning curve that is image processing and turn it into manageable hills for you to get over video by video. Through these videos, I hope to give you the ability to turn a series of images that look like this into a final image that looks something like this, using all of these programs here. I'm going to talk about each one in depth in separate videos, but for this video and the sake of time, I'm going to just brush over what each one of them does and how I use it in my processing workflow. Now, I use the Adobe suite, so a lot of the programs here are paid, but I'm going to go ahead and highlight the ones I consider to be essential for astro processing if you're looking to save a buck. So let's say I've captured a whole night's worth of data, I've got hundreds of frames to go through. My first step's to go to Adobe Lightroom. This is where I import all my pictures and go through them one by one. And I sort out any pictures that have foreground objects that I don't want, like trees if I'm doing deep sky. And I'll also sort out any pictures with clouds going through them, or just poor seeing conditions. Or since my mount doesn't track that great, I usually have to go through them one by one and sort out every other picture that has star trails in it because the mount decided to go haywire for some reason. Now, Lightroom also allows for some light image editing. So if I have single shots, such as like a landscape that I didn't want to stack for whatever reason, I will use Adobe Lightroom for that just because it's easy. It's easily accessible controls there for all the normal settings you can find in Adobe Camera Raw in Lightroom's counterpart Photoshop. So after you finish sorting out all your images in Lightroom, your good images are ready to move on to the next step, which is stacking. Now, if you're new to the hobby, you'll notice that your single images, the object you're imaging, appears very faint. We get around that by using a stacking program to average out the values of each pixel to achieve a higher signal to noise ratio. Now, a more normie explanation of that is it's like you're taking a stamp, but you don't have enough ink. So you stamp it once, you get a faint image, you stamp it a bunch more times, the image starts getting clearer and clearer, and that's basically how stacking works. When you're finished in DeepSkyStacker, you'll get an image that has a lot less noise, but isn't much clearer than your single frames. All the detail and color is there, it just has to be pulled out, and that's where Photoshop comes in. The raw images that come out of stacking are usually pretty dark and lack contrast. This is because the data is still linear and needs to have some curves and levels adjustments applied to look a bit closer to how our eyes would interpret the image. That is, if they were anywhere near as good as a camera is at seeing in low light. This is primarily what I use Photoshop for, along with several other adjustments to really bring out the color and detail in the image. Depending on how good or bad your data is, you may run into several kinds of gradients while processing that degrade the detail in your image. To prevent this, the image needs to be flattened, and while you can do that manually in Photoshop, it's very time consuming and I found it to be rather difficult to pull off properly. So I use the Photoshop plugin Astro Flat Pro to automate the process. It's easy to use and gives you a good deal of control with how it handles the data. It's great for dealing with light pollution gradients or even compensating for vignetting if you didn't have flats for whatever reason, although it's definitely not a replacement for the latter. I also find it helpful to have some action sets to automate the process even more. Specifically, I use the Starizona and Astronomy Tools action sets. These provide automated scripts that add features to Photoshop like automatic star reduction, tools for things like sharpening, increasing star color, reducing halos around stars, and much more. I'll probably detail both of these action sets in their own videos. Your final image can still end up with excessive noise. So the last step I usually do in Photoshop is noise reduction. I typically just use Adobe Camera Raw for this, which is part of Photoshop and has tools for both detail and color noise reduction. But recently I've been experimenting with good results using Topaz Labs Denoise AI, which is a selective AI-based noise reduction and sharpening tool. I also like to find different ways to get more use out of the same data. So sometimes I'll actually batch edit my images in Lightroom and then use Premiere Pro to create a time-lapse of my imaging session. It's quite a unique perspective and allows you to get an idea of how accurate your tracking is and what the seeing conditions were like that night. It doesn't have to be Premiere, you can use any video editor as long as it supports importing images as a sequence. I hope all this gives you an idea of what software you need to get started and how all the programs I discussed are going to work together to help you create your next astro image. In the next videos, I'll be starting by focusing on deep sky astrophotography, but I also plan to dive into other topics such as creating time lapses, star trail images, maybe some planetary photography, and anything else astro related that I can come up with. If you'd like to see more videos in this style, then definitely get subscribed, turn on notifications if you want to be one of the first to watch, and clear skies, everyone. Thank you for watching.